In this video, we're going to look at a few examples of using the shortcut rule for finding derivatives of powers. We have our variable x in the base and a constant power. So in the previous video, we looked at where this rule comes from. It's just what falls out of that limit definition of the derivative when you apply that to a power. So now that we know what we get every single time, we don't have to do that every single time. We can know what the pattern is, and we can find these derivatives just using the shortcut rule for powers. All right, so we're just going to look at a couple of different examples here from easier to harder. So let's first of all say, what if we have a function y equals x to the fifth, and we want to find the derivative dy dx. Okay, so this is a power function, variable in the base, constant in the exponent. So this is just easy application of this rule once you know what the rule is. So we're going to have whatever the original power was. 5 in our case will be out front here. 5 times x to the, and then our exponent here will have 5 minus 1, or we can just simplify that as 4, 5x to the fourth. One thing you want to be careful about when you write these out is not to write that these two functions are equal to each other. The first one is the original function, and then the second one is its derivative, and they are not equal to each other. Every once in a while I see students write y equals x to the fifth equals 5x to the fourth, which isn't true. These are different functions. And the better you can be about keeping track of that, the easier it'll be for you as you go forward. OK, so that one's pretty straightforward. We're just going to look at a couple different examples with some different types of exponents here. So let's look at another example here. If we start with something like y equals the square root of x. OK, so at first it might not seem like that is the same kind of function that we're working with here, but if you remember that fraction exponents are roots, you can rewrite this square root of x as x to the 1/2 power. So when you see these things that are not exactly written as a power, just remembering those exponent rules about how you can rewrite them as powers, and then you can use this shortcut rule to find your derivative. So our derivative, dy dx, is, all right, so whatever our exponent was, we're going to have that out front, 1/2 times x to the. OK, and then in our exponent here, we're going to have 1/2 minus 1. I'm going to go ahead and write that down this time, 1/2 minus 1, and then we'll simplify that. So sometimes I see students getting out their calculator to do this, and although you can do that, the better you get at being able to do this quickly in your head, the better you'll be as you continue through calculus at managing your time and not getting slowed down too much on an exam. All right, so when you're subtracting, you'll often be subtracting or adding 1 for a lot of stuff that we do in this class. So just think about this 1 as 2/2. So you don't even need to write this out. I'm going to write it out this first time here. But thinking about that 1 as 2/2. So instead of 1/2 minus 1, I'm thinking about that as 1/2 minus 2/2. Common denominator, so 1 minus 2 is -1, and then the denominator will be the same. So 1/2 x to the -1/2. All right, and you can leave your answer like that for your derivative, or you can rewrite that as 1/2 times the square root of x, remembering that x to the -1/2 is 1/x to the 1/2, or 1/, square root of x. So either of those would be OK answers for the derivative. Remembering again that those are the derivative, not the original function. All right, let's just look at 2 more examples of kind of just different variations of that. So this is a little reminder about fraction exponents. This is probably the simplest possible reminder about fraction exponents. But we can have maybe one other example of a kind of different fraction exponent sort of situation here. So if I have a different kind of root, maybe a 5th root of x cubed, say, we also want to rewrite that as a power, so then we can use that power rule on that. So kind of looking back at what we did over here, the 2 on the denominator has to do with the fact that this is a square root, and we don't usually write a 2 there, but it's about undoing squares. And the 1 here has to do with the fact that this is x to the first inside. So if you can kind of think about that pattern and rewriting that, then maybe you can remember how you can rewrite this as power. So this would be x to the 3/5. The kind of root is your denominator on your fraction exponent, and the power that's on your x here would be your numerator on the fraction exponent. All right, so that's not really calculus. That's just a little algebra review of something that's helpful in doing this calculus problem. The calculus is applying this differentiation rule to find the derivative. All right, so the derivative of y with respect to x, or dy dx, is, all right, same idea here. Whatever our power was, that's going to be out front. X to the, okay, and let's see if we can do this one in your head without necessarily having to write anything out. So here in this exponent, I'm going to have whatever the original exponent was minus 1. But I want to think about that in terms of fifths. So 3/5 minus 5/5. 3/5 minus 5/5 would be negative 2/5. All right, and you can leave your answer like that. You can also rewrite that sort of like I did over here. You could write that as 3/5 times the 5th root of x squared. Right, so the 3/5 come from this 3/5 here, and then this x to the negative 2/5, that negative exponent puts that expression down in the denominator, 5th root x squared. All right, let's just do one more example here. We're going to start with something actually that starts out sort of like a couple of these answers were, where we have something that's on a denominator to start with, and we want to use power rule to find a derivative like that. So let's look at an example where I start with y equals 1 over x to the 4th. 1 over x to the 4th. All right, and so just like some of these other ones that didn't start out exactly in this form, x to the n, that we have our rule for, but if you remember some exponent rules from algebra, you can rewrite this as x to the negative 4. X to the negative 4, that's just an algebra rule, rewriting exponents. And now I'm going to find my derivative by just using this power rule here. dy dx equals, okay, so whatever this power is going to end up out front. Negative 4 times x to the, all right, be careful here in your exponent. This is a place where I see a lot of students make a mistake. I'm going to write just out here to the side. This exponent here is going to be whatever my original exponent was, negative 4 minus 1. So I see a lot of students, instead of subtracting 1, they will add 1. Negative 4 minus 1 is negative 5. Right, so that's that derivative, negative 4x to the negative 5. Or if you want to rewrite that, you could rewrite that as negative 4 over x to the 5th. Okay, so try some homework problems like that. We'll look at some more videos where we do some slightly more difficult derivative problems.